Hey folks, welcome back. In this video, we're going to add some interactivity to the scatter plot we just created. So for this lesson, instead of a single Svelte component, I'm going to create a new directory. I'm going to copy our scatter plot code into the new directory, and I'm going to rename it main. Now I'll start the development server. So this is where our scatter plot was when we last left off. To start with, I'm going to refactor this Svelte component into two Svelte components. The first one will be responsible for loading the data, and the second one will be responsible for showing the actual scatter plot. The iris entry interface will be useful to both, so I'm going to put that in its own TypeScript file. Now I'm going to create a new component called scatter. Everything that has to do with rendering the scatter plot, I'm going to put in there. Load data will now simply return the data, which will then get passed to scatter. To pass data into a Svelte component, we can use export let. This creates an attribute on the component named data. In main, we can now import our scatter component and pass data to it. Note that when we import a Svelte component, we keep the Svelte extension, unlike when we import TypeScript or JavaScript files. Now that we've imported the component, we can call it as if it was an HTML tag. I'm going to replace all this SVG with this call to scatter. Good, so it works, but it's not rendering anything yet. That's because this component is empty. I'm going to paste in the SVG code that was here before. All of the calls to iris are now no longer necessary because we've bumped up these variables to the top level. So I'm just going to do a find and replace on iris dot. I'm also going to annotate this attribute with the type iris entry array. And we also want to replace instances of JSON with data, which is the value we're getting passed. Species is still a set, so the linter is complaining about it. I'm just going to turn it into an array as soon as we construct it. This array.from is no longer necessary. Now it's stuck in loading. Let's see why that is. Oh, we're still passing the promise, not the data itself. I'm going to fix that. As you can see, we get the same scatter plot as before, but now we've split the responsibility of displaying it across two components, one which loads the data and one which displays it. Currently, this scatter plot is hard-coded to plot the petal width against the petal length. By making it interactive, I want to allow the user to select the dimension for both axes. As a first step, I'm going to modify the scatter component so that the dimension on each axis is a value passed in. Like with the data, that's just going to be another export let. Then, everywhere I use petal length and petal width, I'm going to replace them with x dimension and y dimension. Notice that this breaks the graph because we haven't passed those values in. Once we pass those in, the graph appears again. I'd like to make each dimension selectable with a drop-down element. Since we'll need to use that drop-down element twice, I'm going to make that a component as well. I'll call it dimension selector. For simplicity here, I'm just going to hard code the list of columns. Now I'm going to add a select element to create the dropdown. Here I use each to populate the list of options. Let's render this component and see what it looks like. As you can see, I have a dropdown and it's populated with my options. Of course, it doesn't do anything yet. I'm going to duplicate this dropdown so that we have one for both axes. To get the value back from an input in Svelte, I can bind to its value. To do that, I'm going to create a variable called selected column. I'm going to give it a default of sepal width. Now I'm going to pass that value to select. When I refresh, you can see that this has changed. For now, I'm also going to render the value of selected column so I can show you something. You can see that it is sepal width. If I change this, this does not change. That's because this is a one-way binding. To create a two-way binding, I simply prepend bind colon to value. Now let's see what happens when I change the dimension. As you can see, when this value changes, selected column also changes to the name of the currently selected column. This also causes the component to be re-rendered, updating the selected column here. I'm going to make selected column an externally accessible attribute. Then we can bind to this in turn from the main component. To do this, I simply write export let again. Attributes which are exported are automatically bindable. In the main component, I'm going to add variables for the x and y dimension. Here, I'm giving them some default values. Now, in the dimension selector, I can bind to these attributes. Then I can also pass these into x dimension and y dimension. Now, when I change these dimensions, the plot updates. There's one odd thing happening though. You'll notice the axes aren't updating when the values update. That's because the code of a component runs when the component is initialized, not every time the values update. If we want the scales to change, we have to annotate them so that Svelte knows to update them when the values they depend on change. Here, we want to update the x extent and y extent and the x scale and y scale. To tell Svelte to recompute these when the values they depend on change, we can just change the let to a $:. Now, when I change a dimension, the scale will update. I find these transitions a little bit jarring, so I think it would be nice to animate them. To do this, we can take advantage of Css Animation. I want to animate elements every time their transform attribute changes. I'm going to apply this transition to every object within an SVG. To animate a property in CSS, we can use transition. Transition takes the name of an attribute to animate and the duration of that animation. Now when I change the dimension, you can see the scale animates, but the points themselves don't animate. That's because they're still positioned with CX and CY. If we want to animate their position, we need to position them with transform instead of CX and CY. To do that, I'm simply adding a transform property. Now when I change the dimensions, the points animate alongside the scales. That's all for this lesson. In the next lesson, we'll learn to make a Sankey diagram.